Our first major game theoretic model is the homogeneous goods duopoly model, also called the Cournot model. Here's how the duopoly model works. First of all, the market demand curve, which has been with us all term, remains really a defining fact of life. What's new, though, is that there are two firms, and my demand depends on how much you, the other firm, produces. Given how much the other firm produces, I face a downward sloping residual demand curve. Basically, what's left after what they supply to the market, there's what's left as demand for me. Now, given that, I choose my quantity to maximize my profit. But my answer, instead of just being like the profit maximizing quantity in the monopoly model, instead now it's a profit maximizing quantity conditional on what the other firm is doing. In other words, my answer depends on what they're doing. So we need a more complicated idea about how to come to the answer or the equilibrium. As a first step, let's suppose that the two firms move simultaneously. But I'm getting ahead of myself. We need a lot of nuts and bolts before we can get all the way there. And so let's wade through those nuts and bolts. Let's start with a market demand curve. We've seen market demand curves like this before, so I've referred to it here as our old friend, P equals 100 minus Q. Now, Q, the total amount supplied to the market, is my output plus your output. Let's have costs be zero. Fixed and marginal costs are all zero to keep this example as simple as possible, although it will still convey the important intuitions. Now, I'm firm 1. First question I want to ask is, what's my demand curve if the other firm, firm 2, produces 0? Well then, the demand curve for firm 1 is as follows. P equals 100 minus Q1 minus Q2. So far, there's nothing new here except I've substituted Q1 plus Q2 for Q. But I can rewrite this in a kind of useful looking way by defining the intercept on the p-axis as 100 minus Q2. In other words, the amount the other firm produces reduces the intercept of my demand curve by Q2. Anyways, this intercept minus Q1 then is the demand curve. Now, because so far Q2 is being set equal to 0, this ends up just being 100 minus Q1. So, stepping back again, if the other firm, firm 2, produces 0, then firm 1's demand curve is just 100, P equals 100 minus Q1. Then the marginal revenue for firm 1, MR1, is just 100 minus 2Q1 by our bisecting approach. Setting MR equal to MC for firm 1 then results in a solution of Q1 equals 50. So bottom line, firm 1's best choice is 50 if firm 2 chooses to produce 0. Here it is in pictures, and this is really a very familiar picture for us. This is just a picture of firm 1's best choice if firm 2 were to produce nothing. Well, if firm 2 were to produce nothing, then first of all, firm 1's demand curve is P equals 100 minus Q1, so this red line is that demand curve. Firm 1's marginal revenue curve is the purple line, has the same intercept of 100, comes down with twice the slope, hits the quantity axis at 50. There's the optimal quantity for firm 1. And by the way, firm 1's price, because firm 1 would be alone in the marketplace, by the way, because firm 2 is producing nothing, firm 1's price would be 50. So actually this one boils down to just the monopoly solution. It's as if firm 1 were the monopolist. But now let's consider another possibility. Let's find firm 1's demand curve if Q2 were equal to 50. So if firm 2 were producing 50, then how do we solve this problem for firm 1? Well, now firm 1's demand is P equals 100 minus Q1 minus 50, or just P equals 50 minus Q1. The marginal revenue for firm 1 just bisects that demand curve, so marginal revenue equals 50 minus 2Q1. Setting MR1 equal to MC, remember MC is 0 in this example, gives us a solution Q1 equals 25. In other words, firm 1's best choice is to produce 25 if firm 2 chooses 50. Now this is starting to look systematic. I mean, the answer is that depending on what firm 2 produces, I, firm 1, have a different best response. This diagram just adds to the previous diagram a demand curve for firm 1 in the event that firm 2 produces 50. When firm 2 produces 50, then firm 1's demand curve has an intercept on the p-axis of 50. It still has a slope of -1, so firm 1's demand curve when firm 2 produces 50 hits the quantity axis at 50. And the marginal revenue curve for firm 1 when firm 2 produces 50 hits the quantity axis at 25. Because MC is 0, that 25 is firm 1's best response when firm 2 produces 50. Now we can connect the dots, and this has a name. It's called the reaction curve. But let's be clear about what these dots are. On this axis here, we have firm 2's choice. And remember, we started with firm 2 producing 0, and we found that firm 1's best choice, which is on the vertical axis here, was 50. When firm 2 produced 50, we found that firm 1's best choice was to produce 25, and that's this point right here. What we've done here is connect those dots, and this line is called the reaction curve. For this problem, it is that Q1 equals 50 minus 0.5 times Q2. What this shows is that, well, first of all, this shows firm 1's best choice for quantity to produce as a function of what firm 2 chooses to produce. Also, going a little deeper, it shows us that the more that firm 2 produces, the less that I, firm 1, want to produce. That's a sense, or that's because this is negatively sloped. That is, the bigger this is, the smaller this is. I mean, it's not unintuitive. Think about me being a monopolist, and I have a best quantity. Now imagine shrinking my market because of what you're doing. If you were to shrink the market, the best thing for this monopolist to do would be to produce less. We have another way that we can get the reaction curve. We can start with the demand curve that firm 1 faces. P equals We have another way of getting the reaction curve. We can start with the demand curve that firm 1 faces. P equals 100 minus Q2 minus Q1. And let's think of this first part in parentheses as the intercept on the p-axis. That intercept gets lower as Q2 gets bigger. That is, the more firm 2 produces, the lower is the intercept on firm 1's demand curve. Well, thinking about the demand curve as P equals an intercept minus, well, a slope times the Q1, we can just get the marginal revenue by bisecting the demand curve. So what we can do is we can say that MR1 equals that same intercept minus 2 times Q1. MC is still equal to 0, so we can find the best Q1 as a function of Q2 by setting MR1 equal to MC. And in this context, that means 100 minus Q2 minus 2 times Q1, that's MR1, equals 0, and that's MC. If we solve that for Q1, we get that Q1 equals 50 minus a half Q2. And sure enough, that again is firm 1's reaction curve. And we got it this time just by understanding that the intercept has changed and using the bisecting idea. So far, all we have is the reaction curve for the firm. That is, we have the best thing that firm 1 can do given what firm 2 is doing. What we need to do from here is to find the market outcome, the actual equilibrium. And for this, we need some new notion of equilibrium. These two pictures down below are relevant here. The picture on the left is a picture of Russell Crowe in the movie A Beautiful Mind, he was playing a man named John Nash. John Nash is the man depicted on the right here. You can see Hollywood took some liberties here in casting. But importantly, John Nash is going to give us some idea about how to solve this problem. So what's the relevant equilibrium idea? Well, prior to today, our equilibrium idea was that, well, firms are doing the best they can and they have no incentive to change their behavior. And so, for example, the single price monopoly pricing model, the equilibrium for that was, the Q that has MR equal to MC. Now, though, we need a little bit more subtle concept. We have to have that each firm is doing its best given what its rivals are doing, while at the same time, the rivals are doing their best given what we're doing. And this is actually Nash equilibrium. And so yes, now we're in the realm of game theory, and there will be more on this a little bit later in the course. But we'll use this idea directly right now. So let's go back to firm 1's reaction curve. What the reaction curve tells us is that for anything that firm 2 might do, for any Q2 between, say, 0 and 100, firm 1 has a best response that's between 0 and 50. Let's illustrate this. Suppose that firm 2 chose 25 and firm 1 chose 37.5. Well then, 1 is doing the best that he can given what 2 is doing. How do I know that? Well, think about firm 1's reaction curve. It's Q1 equals 50 minus 0.5 times Q2. If firm 2 is producing 25, then this equals 50 minus 0.5 times 25, and it equals 37.5. So sure enough, if 2 chooses 25 and 1 chooses 37.5, then yes, indeed, 1 is doing the best that 1 can given what 2 is doing. But is this an equilibrium? Well, we have to ask the question from 2's perspective. How about firm 2? Is 2 doing the best that he or she can given what 1 is doing? Well, firm 2 has a reaction curve as well, which we could use to figure out the answer to this question. Everything about this problem is symmetric, meaning it's the same for firm 1 and firm 2. So firm 2's reaction curve looks just like firm 1's reaction curve, except that we've switched the subscripts. So firm 2's reaction curve is that the best Q2 equals 50 minus 0.5 times Q1. So let's ask the question, if 1 is producing 37.5, what's the best response for 2? And the answer is the best response for 2 is to produce 31.25. Now that means that this combination Q1, Q2 of 37.5 and 25 that we conjectured on the last slide, that's not an equilibrium because the firms aren't both doing the best they can given what the other is doing. Well, this seems really helpful. We've just found an answer that's not the answer. So how do we go and find the answer that is the answer? Well, the way we get to equilibrium is to find the intersection of their reaction curves. To say it another way, the only way for both to be doing the best that they can given what the other is doing, and for neither to have an incentive to change, is to literally look at the intersection of the reaction curves. So what this picture below shows, which has quantity produced by firm 2 on this axis and quantity produced by firm 1 on this axis, it has the reaction curves for the two firms. The blue line here is firm 1's reaction curve, which remember was Q1 equals 50 minus 0.5 times Q2, so it goes from here to here. The red line is firm 2's reaction curve, and Q2 is equal to 50 when Q1 is 0, and it similarly declines, that is Q2 gets smaller as Q1 gets bigger, and so it hits the Q1 axis at 100. The intersection is going to be the equilibrium in this model. That's the place where each is doing the best that he can, given what the other is doing, and the other is similarly doing the best that he or she can, given what the first is doing. Now mathematically, we can get the answer by simply solving the reaction curves together. So here's firm 1's reaction curve, and here's firm 2's. We can solve them together by plugging in Q2 right here, and we have just a little bit of messy algebra, not too much. We get that Q1 equals 50 minus 25 plus 0.25 times Q1, or that Q1 times 1 minus 0.25 equals 25, or that Q1 equals 25 divided by 0.75, or that it equals 33. Now remember, all we found here is what firm 1 produces. We need to know what firm 2 produces. So let's go plug it into firm 2's reaction curve. Q2 is 50 minus 0.5 times whatever firm 1 is producing, which is 33 1/3. And that turns out to be 33 1/3 as well, which shouldn't be too surprising because everything about this model is symmetric. By the way, it wouldn't be symmetric if these firms had costs that differed, but these firms both have zero costs, zero marginal costs. Anyways, back to our story. Since each firm's producing 33.33, total output is the sum of what the two firms are producing, 66.66, and the market price, well now for that we have to go back to the market demand curve. Remember, the market demand curve was P equals 100 minus Q1 minus Q2. So if we plug in 100 minus 33 minus 33, we get that the price is 33 1/3. Well, let's compare duopoly, this Carnot-Duopoly model, homogeneous goods duopoly model, to monopoly. So here's the monopoly version of the model. We start with the same market demand curve, and let's have the same marginal costs and fixed costs all zero to make the comparison a fair one. So all that's different is that there's just one producer here, whereas in the previous slides we had two producers. So the marginal revenue is 100 minus 2Q. Setting that equal to 0, we get that Q equals 50. Plugging 50 back into the demand curve, we get that P equals 50. And profit equals 2,500. Compare that to the duopoly profits. Well, in the duopoly case, we had two firms, each of which had as its profit P times Q1 and then minus no costs, minus 0. And so that was 33.33 times 33.33, and that equals 1,111 per firm, or 2,200 overall. So combining across the two duopoly firms, there's 2,222 in profit, whereas a monopolist would have 2,500 in profit. A diagram makes for a nice comparison of Carnot-Duopoly versus monopoly versus competition. Let's start with monopoly. So this we have the market demand curve here and the marginal revenue curve associated with the market demand curve, or if it were the monopolist's firm demand curve. And of course the answer, that I say of course because we've done it already a few times even today, the answer is that the monopolist produces 50 units of output and charges a price of 50. In Carnot-Duopoly, we found that collectively the firms produced 66.7 approximately units of output, and the price on the demand curve then was about 33 1/3. Well, it was exactly 33 1/3. So we see that duopoly relative to monopoly has higher output and lower prices. We could also compare competition. Now remember, this is a situation with zero costs, so it's a little bit funny. Perfect competition would give rise to drive prices all the way down to marginal cost, which is 0, and so that would put us here at an output of 100 and a price of 0. But I guess the deeper point is that the larger is the number of firms, n, the more we move this way toward higher output and lower prices. One could literally do a model of n-opoly. As n gets large, the model gives the competitive answer, which is down here. So what are the takeaways from this video? Well, there are a few. First, with two producers of a homogeneous good, the price depends on the sum of their outputs. The demand curve is still governing our lives, but what determines the price is the sum of Q1 and Q2 to get to total Q, which in turn determines P. Second, now the best quantity choice for each firm depends on the quantity of its rival, and that's what we summarized in the reaction curve. It's my best output as a function of how much output you produce. Third, given these reaction curves, Nash equilibrium gives us an answer for the simultaneous move game. That means the equilibrium in this situation is that I'm doing the best that I can given what you're doing. Well, you're doing the best that you can given what I'm doing. And Nash equilibrium is the solution to that. It's the intersection of the reaction curves. And finally, a more kind of common sense interpretation of all this, or implication of all this, is that as the number of firms increases, Q rises and P falls along that market demand curve.